Right, this 2000's paper, first questions, part A, right, differentiation and integration. Let's start with a differentiation of this function. I'll review a little bit about differentiating a ln function. So if you have a ln function like this, so it could be fx here, this is an expression here, fx. When you differentiate it, all you have to do just don't have to care about anything, just whatever being displayed here, you write this and then you differentiate the fx and to get your df dx, and then right here, and it will be a rational function. So that's all you do. Okay, now so y is your ln x e plus e to the power of x. So that means dy dx, all you have to do is it's always in rational. So let's copy this, x to the power e plus ex, and now you differentiate this. Now, e is just a constant, just basically a number. So it means that when you differentiate xe, you get ex e minus 1. Okay, so just a number. So you actually can just do that, x ex e minus 1 plus ex. And you do not have to simplify this, so that's it, right? Now part B is substitution is required. If you're very skillful, in fact you can actually integrate it directly. But before we actually integrate, I will talk about some guidelines on substitutions. So if you see a function like this, you see, say, integrating fx, and then there is a eax. Immediately you probably, it's probably a good idea to substitute this ax by u. Okay, whenever it's the in the exponent part of this expression, and suppose you have something like this, fx, and then you have ax here as your denominator, and again is normally a good guide to then substitute the denominator by u. Alright, what are the guidelines I can give you? Alright, if you have see something like this, see it's a function, ax is like in the radical, it's a radicand, and so again it's a good idea to let u be ax. And one more, probably these are just guidelines. You see, they are not like any particular rules. Sometimes they do not work. You have to make your own judgment sometimes. Right, if you see like something like this to the power of n, and probably see a function fx here, and again it's a good idea, again you let u be ax. And so looking at B, is we find that this is something in between the situation, something in between of situation in D, and so situation in D mainly. So what we do is, well, immediately we think that if we let u be this, and the ax for us now is this expression, so let a be that, or u rather be that, and so your du dx is as this one, and so your du is equivalent to 6x squared minus 2x plus 2 dx. Of course, I will try, it's a common factor 2, I do that, factor the 2 for a very good reason, because now you find that this 3x squared minus x plus 1, this expression is exactly the same as this. And now, okay, we're ready to substitute. So the original problem, okay, you must write something here. I'm just being lazy. And now we're going to substitute this. So this becomes, I think I'll write one more step to make it clear to you, plus 1 square, and then this is actually 3x squared minus x plus 1 dx. right? When you substitute this becomes u square, and this is du, but of course this is actually half du, because you can actually multiply both sides by half and you get this dx equals to half du. So this is half du, and you integrate this, the outcome would be u power of 3 6, okay, plus c. Now don't forget what u is. U is in fact that expression that we substituted, so we just place it back into there. 2x plus 1 plus c. Okay, right? And moving on to another questions. I think let's see. Perform the integral. Wow, this seems very difficult, but sometimes if you keep calm and think through the problem, you see that how simple it is actually. And I'm just gonna show you why it is simple. I'm going to do this because we know the sum of function can be written as follow. Like I can, as if I'm doing the two integrals, right? Integration 2 times, and this shouldn't be a problem to for you. But here 1 over square root of 1 minus 2x is in fact, what is it? Right, it's 1 minus 2x negative half, right? Because 1 over something a is 1 over a power half is then a to power negative half. So if you a is 1 minus 2x, then you have it. And so this is this e3x using the table of integration, and this is 1 minus 2x, again using a table of integration. This is negative half plus 1, and the outcome is negative half plus 1. We need to multiply by negative 2 here. Just follow the table, plus c, and then you end up with 4 over 3 e to the power of 3x, and this is negative 1 minus 2x power of half, okay, and plus c, right? And the last one, let's do this. First we use law of log to simplify this, and so I can then write like this: e power x is a product, so it's addition of these two, 3x plus 2, and then of course another, using law of log, I can do this ln e, as if writing the 4x right in front, and then nothing much I can do with 3x plus 2, just keep it as such. And of course this is 1, so I get 4x plus ln 3x plus 2, and so the dy dx then, so we have simplified it, and so the dy dx is then differentiating this, you get 4, and differentiating this again, recall this now. How do you differentiate ln x? You don't care, just write a fraction, you copy the function here and then differentiate the function, and that the outcome is 3 only, right? So just write 3, and that's your work. And hope you try it again, and all the best.